Hello, everyone. Welcome to another class of IGCSE Chemistry. I'm Dr. Yu from Guiyang Prime International Academy. Today, we're going to talk about the rate of reactions. As you may notice, I put the word pandemic control in today's title as well. As a whole country, I would say, in the past 3 months, what we have achieved was so remarkable that even people in other countries start to question about it. They choose not to believe the data we announced. Whatever. After today's class, I would say you will have a better understanding that all the precautions we have been taking were based on science. And it is deeply related with the contents we're going to be covering today. Without further ado, let's get started. At the beginning of the class, I'd like to show you several pictures. First is the ones about supermarkets abroad. In the beginning of this pandemic, like at the beginning of March, in other countries such as in North America or in European countries, you probably saw the videos of people like rushing in supermarkets start to fight for the living stuff. And in both of those pictures, they were showing the counters for toilet papers. And you may start to not so easy to understand why they are fighting for toilet papers in this hour. And I would say probably part of the reason that we cannot understand it is like in our own country, those type of things seldom happen, which we are running out of living stuff, basic living stuff. I would say what's behind it is like we have successfully dramatically increased the production rate. And what is behind that is we accelerate the reactions, chemical reactions, thousands of them. But is it always true that we want to accelerate a chemical reaction all the time? Let's take a look at another set of photos. It could be as large as a forest fire, and it could be across the whole country of Australia. And it could be as small as something you put in your fridge. And those are all chemical reaction related. You not only want them to accelerate, you want them to get slower. What is better, you want them to stop. So you start to get an understanding that if we want a chemical reaction to serve us better, we want to control them. We do not only want a gas pedal, but we also want a brake so we can manipulate the rate as much as we want. So in order to understand what is going on in that, we need some tools, which is the first part we're going to cover in today's class, which is collision theory. A theory is something that you can call that as an idea or a model come up by some people, mostly scientists. A good theory can be a very good tool for us to understand this physical world. As for chemical reactions, they are the things going on between molecules, atoms, or ions. They are so small and so intangible. So that's why we need something to understand what's going on between them. As for collision theory, let's take a look at what the textbook has described this theory. In this paragraph in the textbook, it basically talked about how the chemical reaction can happen. First, the reactant need to come together, and they need to be in the same place at the same time. But is that enough? The other thing that is required is sufficient energy. And they not only need to come together, but they need to come together with sufficient energy, which is a collision. And there is a very brief Chinese translation about this whole paragraph. It could be only 4 characters in Chinese, which is 有效碰撞. So you can have an understanding that how powerful our own language is when we try to describe something. And this collision come together and with certain sufficient energy. I wonder if you can think about something that we have been talking about a lot recently, which is 密切接触. Yeah, you need to contact, not only contact, but you need to be close enough. And I would say the concept of this 密切接触, it is quite crucial in this pandemic control. Why is that? If we have a better understanding of this concept, we can identify and, more importantly, track the people who could possibly get affected. And that is very important. And as for our own individuals, each individual, it is also important. If we understand that term better, we will avoid those dangerous places as much as possible. And also, in the meantime, it kind of ease our minds. Why is that? Because we will understand if we can get affected and need certain criteria, which is not only contact, but also in a certain way. So we don't need to worry that much. That is very important in a crisis like this. And if we can understand this word or this concept very well, I would say you will have no problem understand how the reaction can happen. And need not only come together, but also with sufficient energy. Yeah, that is what we said about this collision theory. Okay, let's move on to the next part, which are the factors of affecting the rate of reactions. First, I would say is the easiest one, is the effect of temperature. In order for you to help you understand this term, I would like to show you a very interesting video that became viral during the Chinese New Year on the internet. Yeah, it is a very short video. I don't know whether you have seen this before, that there's a female try to wake up her husband, like probably complaining about he sleeping too much during this time. And he is very angry about that because, like you said, the government says obeying the government order. I would say that the government never say something like that. It's like it encourage us to stay at home as much as possible. It never say sleep as much as possible. But the way of doing things of this man, I would say, is very important and is efficient for minimize the contact with other people. As you can see, if we minimize our own activity, we will minimize the possibility of contact, which slows down the spread. This makes sense, isn't it? And if we think about the individual as a molecule or atom, if they become more high pressure, they will be more active and there will be more chance for them to collide. That is how the reaction rate, how the temperature affect the reaction rate. Let's take a look at what the textbook has described the effect of temperature. When you heat up a substance, energy transferred to particles, and whether in solution or gas, the particles will move around faster. As a result, they collide more often. Blah, blah, blah. This is like a whole paragraph even for the effect of temperature. But is there any very simple translation of Chinese. It can like cover this whole paragraph. Then in the previous one, we use 4 characters to cover up how the chemical reaction can happen. Can you think about like even more, even shorter, like sentence of Chinese? And what I think about is like this 2 word. It's called 热闹. When we heat it up, when we get hotter, the particles start to be more active. It started to gnaw. And the 热 may be the reason, and the gnaw became the result. But it also could be the other way around as we uh, think about what's going on in the microwave oven. Because those particles are more active, the temperature starts to rise. So this 2 word, I would say, can describe what is going on in this sentence. Is how the effect of temperature affect the reaction rate. Okay, after the temperature, let's take a look at another fact, which is the effect of concentration or pressure. Before that, I would like to show you a couple of pictures of our school that happened like after the pandemic and then before the pandemic. This is what's going on in our typical flag raising ceremony. What the picture on the right is what happens like 2 weeks ago. What the picture on the left is one took in last semester. As you can see, the students like in this crisis in our Guizhou province, we are one of the first province that reopened our school. It dates back to the middle of March, the March 16th, which was the first day of our school. At that time, I would say the situation is way more serious than what's going on right now. And we need to take precautions. And the precautions we take is called like zero contact. Zero contact between what? We cannot be zero contact between the teacher and the students or the students in one class. The zero contact is like the students between different classes. For each class, they will have their individual laboratory, their individual area for outdoor activities. And when they eat, and they eat at their individual classrooms. And even during the a gather, like a flag raising ceremony, each class was called out like at different time, like at least 1 minute between them, and a huge space between them as well, as you can see. And what I've been doing in here is like maximize the space between them as much as possible. As we have like the big campus, that's what we can do, and we'll have been doing like even until this day. So it's quite easy to understand that we need to keep a minimum distance between students. But if we think of those students as molecules, if we increase the distance between them, we will definitely decrease the possibility that of the collision. As we can take a look at what's going on in our textbook, is the more crowded together the reactant particles, the more likely they will collide. It is quite easy to understand. There's another photo from the textbook. As you can see, they are more crowded. It is easier to get a collide, and the reaction can happen faster. And that is the effect of concentration or pressure. Okay, let's move on to the last one we will talk about today, which is the effect of surface area. I put it at the end because I think it is the most interesting one of today's lesson. First, I'd like to ask you a question, which is, can you come up with like a part of your body that have big surface area? Like it could be a part, it could be an organ, anything. The one that I have come up with is our lung. As we talk about a lot during this time. Our lung is very interesting in its structures and it's complicated as you can see. And the surface area of our lung, you may guess, is how it is very big number. It could be more than 100 meter squares. 100 meter square. You may say, maybe it's not that big. You cannot get an idea. But think about it in this way. If you put lung of a normal adults and spread it in a decent apartment, it could possibly be filled up every inch of that apartment of 100 meters square. That is something very horrifying. That's how the structure is to help us in the process of respiration. But during this virus thing, if the virus get into our lungs, it can attack at any space in our body. And I would say that is why it is so important to wear a facial mask during this time. It will block the virus from accessing such big surface area organ. And can you think about something else, like way bigger than a lung, which is have a big surface area? Yeah, the one that I'm thinking about so big, it could be a city. In a city, as you can see on the map, it is a very porous structure. It is connected like from every direction to almost everywhere. And during such pandemic hour, I would say, the city becomes the worst case scenario for the spreading of the virus. Why is that? I would say because it have all the features that we have talked about to accelerate a reaction or the spread of a virus. First, I would say the people in a city are way more active. They see more people, they go to more places, they are way more busy than anywhere else. If we think about that as refer that as a molecule, it is as active as possible due to the high temperature possibly. And the second one is concentration. The city is a very crowded place, and it could be tens of millions of people crowding in such limited space. It's just like we make a solution as concentrated as possible, or the gas pressure is as high as possible. And that will increase the possibility of collision. And as a result, they increase the rate of reaction or the spread of the virus. And the third one, as I mentioned, the city is a porous structure. It is so convenient for us during normal times that we have very convenient transportation. We can go anywhere. But in this hour, it became more vulnerable in front of the virus. If the city goes on and function as before, as in normal times. And that is why I would say, due to these three factors, if we understand them, you will have an idea why the city is such a dangerous place to be in this pandemic hour if we take no precautions and take no orders from the government. And for the photos I choose, it is not an ordinary city. It's not a random chose city. It is Wuhan. And I would say we can like give a class in this hour at like a relative comfort environment. But my friends, I have a lot of friends back in the US. They are probably all teaching assistant, even professors in the US. They also are giving online classes at this hour. But the situation they are in and the mood they are right now, I would say is definitely different from us. I would say this big difference is largely due to the heroic actions of the Wuhan people and those who have helping them from all over the country. We need to be grateful for what they have done, and that is why it's like it's so important to for us to understand the the precautions we have taken in the past 3 months. Okay, that is mostly of today's class. Yeah, the textbook have like talked about the surface area is the size of the piece of the solid could affect the reaction. But as I talked about like some porous structures with like high surface area, I would say the description of the textbook is not enough. The structure of reactant also matters, as well as the size of the pieces. Of course, the smaller it is, the bigger surface area, but it could be a very big reactant. Even you can think about a city, you can consider that as a reactant. The structure also matters in affecting the surface area as well as the reaction rate. Okay, and in today's class, in the first place, we have mentioned, talked about the collision theory, which helps understand what is so intangible, the chemical reactions. With that in mind, we can better understand the effect of temperature, which is if we increase the temperature, the molecules become more effective, more active. There will be more chances for them to collide between each other. So that is why we need to be stay at home, is to become as inactive as possible. And the second factor, which is the effect of concentrational pressure, the more crowded they are, the more possible of a collision. And that is why we need to avoid as much as possible a gathering, yeah, to go to a crowded place. And the last one, which is the effect of surface area. The bigger the surface area, the more possibility of like a collision can happen. If we think about the city or to think about our like large surface area organ, like our lungs, we need to block it or make it stopped functioning as before. And that is how the surface area affect the rate of reactions. As you can see from today's content, it's not so hard to understand, but we can link those concepts with the ones we have been going on in our daily lives. That's, I would say, is how charming the chemistry, the subject of chemistry. If we have like a certain knowledge, even the basic knowledge of chemistry, you will see this world in another perspective, in a more perspective way to understand what is going on around us. And that is why I would say I love chemistry so much. And if the Western people, as you can see on the news recently, a lot of people in the US like start go on the street and protest against the stay-at-home policy. If they have a basic understanding of chemistry, of how we control the rate of reactions, I would say they're probably not going to go out like that. Okay, so this is the class of today. Thank you for listening.